Okay, well, perhaps we should get underway. Welcome, everybody. Happy New Year. And we start the new year 2023 with a community advisory group meeting. Thank you for attending. And we have some presentations that I think are extremely relevant given the current weather conditions out there, as we'll get into the rest of the agenda. First, I'd like to see if we have any questions, comments, updates from CAG members. This would be announcements, any events that are taking place in your organization or elsewhere within the community and for which you would like to inform your fellow CAG members about. So just checking in with everybody. Are there any events or happenings of note that you'd like to share with the group? One point is Maria is also indicating our 2023 meeting dates have been sent out. Make sure you have all those dates in your calendar. We'll review those again at the end of the meeting, but the next one being March 13th. So make sure you have that one in your calendars. Any updates or announcements that you'd like to make here before we get officially underway with our agenda? You can raise your hand or the real one or the digital hand. Okay. Not seeing any at this point. So why don't we proceed in that case into our operations update? We like to begin with our Deputy Lab Director, Michael Brandt. So Michael, I think we're ready for your update.
Oh, great. Well, first of all, Happy New Year and welcome everyone to 2023 and our first meeting of the year. I've been looking out my window because I see something I haven't seen much of, which is the sun setting. And tonight's meeting we'll share some information about extreme weather we've all been experiencing, and actually we didn't plan it this way, but our featured speaker will be talking about climate change and impacts on our weather patterns. So in our first slide, I do want to, there's something still called COVID that's within our community. And I want to tell you that our new COVID case rates have decreased enough for the state of California to either be in low community risk or moderate or medium. And what medium means for us in this region is we still encourage, and we encourage our lab employees to stay up to date with the vaccines, get tested if they have symptoms or they've been exposed to someone who has COVID. Wear a mask in public, that's optional. And also you may choose to wear a mask at any time. So if you look across the United States here on this map, the Eastern United States is experiencing high rates of transmission, which could be related to the one new variant. But in the Mountain West and the western portion of the United States, we're in either low or medium transmission. So that's good news for us. And in this next slide, you'll see that at our laboratory, this is a chart that we've related to our safety protocols that we've used, that we've developed and we continue to use to share what is required and what the expectations are for anyone coming to the laboratory based on the transmission rates and the community risk levels. And you can see what this looks like. And we're in medium. And right now, we're encouraging people to wear a mask at any time if they so choose. And we also encourage them to maintain physical distancing, and we want everyone to feel that they're welcome to communicate and work in groups as long as the groups are comfortable doing so. We still, right now, we have about somewhere around 45 to 50% of the lab's population comes to the laboratory site each and every day. And on this next slide, I'm going to transition to what we've all been experiencing over the past couple of weeks, which is extreme weather. And our laboratory, just like the rest of the community, we've had, fortunately, we've had some minimal impacts. We've had 2 trees that have fallen. They fell over the break. We have a contract with the a tree removal company, and we've actually had 2 of these trees that you can see here in this image that were removed from the roadway, and we actually removed another tree that was a hazard tree at the lab, and we'll continue to monitor the lab each and every day for potential hazards associated with vegetation. And just as we have across our region, we're taking care of everything from drains and roofs. And we have had our fair share of roof leaks. And so we monitor that in real time. We partner with our emergency services and safety organization to report any potential challenges that we have around the site. And we're taking every measure that we can to repair our roofs as needed. And we've been quite fortunate that we haven't had a tremendous number of roof leaks, but we still have those. And we continue to monitor our weather forecasts and take actions as appropriate. And so in this next slide, I don't need to tell any of you, we're all living through this, but for the foreseeable future, NOAA is telling us certainly through this week and possibly through the rest of the month, we'll have above average precipitation in our region, which means that we all need to continue to stay vigilant and protect our homes, our neighbors, and certainly here at our laboratory to protect the laboratory as best as we possibly can. For your interest, we do have a weather station here at the laboratory, and this weather station is located by our advanced light source, and it's available to the public, and you may be interested in this, give you information on various weather parameters, and this you can access it either using this QR code or that link that's listed here on this chart. I do find these kind of data to be of interest, and so that's publicly available if you're interested in that kind of thing. And so then shifting gears entirely is that you may not, I don't know if I've actually talked about this in the past, but our laboratory and each national laboratory, there are 17 around the DOE complex, each laboratory is assessed and our performance is rated by the Department of Energy against these 8 different rubrics, ranging from mission accomplishment, this related to our research and development work, through construction and facilities and maintenance and emergency management. And for the second year in a row, we've received straight A's. Now, it might seem odd that we would be graded, but these grades are quite important because it reflects the level of commitment across our entire laboratory and about leadership and our employees caring for one another for our research, to accomplish our important national mission. And the last time that a laboratory received 1 year of straight A's was in 2006, and we've managed to repeat that 2 years in a row, and that reflects the level of commitment that we have across our laboratory to commitment to quality and commitment to executing our mission safely. And then in the final thought today is to share with you some outstanding news. We received news at noon today that the Seismic Safety Modernization Project, which is effectively the replacement cafeteria for our existing cafeteria, which is the last and oldest cafeteria complex in out of the 17 national labs. We've now have approval to begin the construction of the facility, and then following that, we will begin the construction of the foundation on the hillside and begin this project in earnest. And that work will begin this winter and spring. We'll be mobilizing the contractor, and this is a tremendous accomplishment for our laboratory. And the project itself is now a $140 million project, and part of it reflects the cost escalation related to COVID, supply chain challenges, and just labor costs have increased over time. And so we're excited about this. We're looking forward to beginning this project in earnest. And we expect that we'll complete this project in about 3 years. And this was the first project I began working on 5 years ago when I joined the laboratory. So these projects have a long gestation period. And so from start to finish, it will have been roughly an 8-year process to get this building constructed. And we're very proud of the fact that we now have the funding, and we have an outstanding contractor, and we're looking forward to completing that project. And so those are my remarks for this evening, and I'll open the floor up for any questions that you might have.
Very good. Thank you very much, Michael. And why don't we see if there's any follow-up questions or added comments to the operations update? Anybody? Again, raise your hand or show me the digital hand.
Let's see if I can do that. Hey, how about if I just give a shout out?
Go ahead.
Mark Scandari here. Just wanted to do another shout out. I changed my outgoing photo to the sunset tonight. I had to go up and do a sneak peek. Just want to see if it's possible to add a pollution index to that weather station at all.
I'll have to talk to the people who own the monitoring station. I'll ask them.
Definitely, thank you.
Yeah, you're welcome.
All right. Thanks, Marco.
Okay, thank you.
Any other questions or follow-up points?
Oh, I also want to follow up if they do, because of I do see a differentiation between lower elevations and higher elevations. Be one if they could actually add other ones around town as well.
Yeah.
Right,
I think we use this station is for our own internal monitoring for the site, but I'll find out whether or not we're connected to any. We may be connected to other weather stations in the community, but I'll ask.
Thank you.
I do have a partial response for you, Marcus, is that LBNL has the environmental services group who runs that weather tower does have several other carbon monitoring stations, but they are not on our Hill site. They're elsewhere.
Mhm.
But
Okay.
you can also find that information through that link. There's a whole bunch of dashboards that you can explore.
Exciting. Thank you.
All right.
Thanks, Katie.
Thank you, Katie.
Okay.
I'm not seeing any other questions or comments at this point. So we shall move on to the next item, which is a presentation by Michael Wainers, a senior scientist with the Computational Research Division at the lab. And his topic is extreme weather events in a changing climate. So here we are, we're living it out as we speak. So Michael, why don't you take it away?
Thank you. Yeah, indeed. Everybody's talking about the weather this week, that's for sure. My camera has been flaky, so I'm going to turn my camera off for now because it can get distracting. It's doing it right now, in fact. But this should work with the share. So let's see.
Okay, it's on the screen, Michael. We're good to go.
All right. So this isn't us. This is Hurricane Harvey. And my title is formally End-to-End Attribution from Hot Air to Environmental Injustice. And I think that kind of says in a word what I'm really interested in, because climate change does not affect everybody equally. And I'm sort of in a position to address that question. And I'm going to use Hurricane Harvey as an example, but because that's what we've written most about. But the methods and some of the results, I think, are quite extensible to other places, including us here in the Bay Area. And you can see this was quite a disaster for the citizens of Houston. So this is my standard disclaimer that these are my opinions, not that of the laboratory, the University of California, or the Department of Energy. I speak for myself. So what I do is something called extreme weather event attribution. And we typically ask two questions, and this is a causality kind of question. And causality of complex events is a complex thing, obviously. And so we wouldn't say that climate change causes this particular storm we're having right now. But we might say, how does the probability of a storm of this magnitude change because of climate change, because of global warming? Or how did global warming affect the magnitude of this event if you fix the probability of, say, the once in 20-year storm or something? And this is some work I did for the Pacific Northwest heat wave. And it shows that these are really two sides of the same question. If you look at this plot, which is a plot of something we call the return period, which is like, once in 100 years, for instance. And we look at the y-axis, which is the magnitude, and say, okay, well, once in 100 years on this red curve, we'd say, well, it's about 315 degrees Kelvin. I'm sorry for the bizarre units that we use here. And what we did is we ran simulations of this heat wave and looked at it two ways, with the world with climate change in red and the world without human climate change in blue. And if we fix the magnitude and say, like, what's happening at this temperature of 314 degrees Kelvin, we say, well, now it's like a 1 in 30-year event. If you go over horizontally to the red line and then drop down. If you go all the way over to the blue line, you can see, well, it's a much rarer event in a world without climate change. It's like once in 200 or so. And so we would take that ratio and say that climate change made it X times more likely. If we ask the other question, how did it change the magnitude of this event, fixing the rarity? You say, look at, say, 1 in 100 years. So pick 100 years off the x-axis and go up to the blue curve and say, oh, well, it's about 313 degrees without climate change and 315 degrees with climate change. And so we would say, well, in this case, for an event of this magnitude, climate change made it 2 degrees centigrade, in this case, warmer. And I actually made an attribution statement that because this is a very robust result on heat waves, that through the United States, for any kind of garden variety heat wave, once in 10 years, once in 20 years, once in 50 years even, climate change has made that 3 to 5 degrees Fahrenheit warmer with the current amount of climate change. Of course, as we continue on in time, there'll be more climate change regardless of what we do. And those numbers will get larger. Now, we have a choice of how much larger by either reducing our dependence on fossil fuels or not. So, but what I'm really getting at is not so much the weather, but what it does. And so I'm a physical climate scientist. I've really been focusing on the weather itself, but now I'm sort of moving into the impacts. And these are slightly different questions. So not how much climate change changed this event, but how much climate change cost in this event. And that could be either financial or it could be human. How many people died because of climate change in this event? Or even very personally, the questions that I get: did climate change flood my house? Or did climate change kill my loved one? In these heat waves, most of the people that die are the vulnerable, the very young, the very old, the very ill, and the very poor. And these may or may not be tractable questions. It depends a lot on the context. But fundamentally, I think they're linked to this change in the magnitude question, the 2 degree thing, rather than the change in the probability, which is what you often hear in the press, because even though these are the same statement, you might hear that climate change made this 30 times more likely. That sounds bigger than this is only 2 degrees warmer, even though 2 degrees is actually a lot. And reporters tend to glom onto the bigger numbers. I talk to a lot of reporters, and that's sort of what they want to hear. I don't always tell them what they want to hear. I tell them what I think. Which they don't always, which is not always a very, 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 very nice story, quite frankly. This is Hurricane Harvey hitting the coast of Texas. A satellite image is repeating itself, which is right there. What made Hurricane Harvey really bizarre is that it stalled and it just slowed down. The numbers here are the dates in August and then into September, and you can see around the 25th, it just decided to hang out there. And so it produced copious amounts of rain. In some places, 5 feet of rain in a week, which is, even more than we're getting now. 3 independent groups, including myself and Mark Risser at the lab, analyzed this precipitation increase due to climate change. And we used different methods and different data sets, and we all came up with answers that were within each other's confidence intervals, within each other's uncertainties. And before the event, I thought that there was this law, this 19th century relationship called Clausius Clapeyron, two old guys who did this for steam engines, who found that the amount of moisture that the atmosphere can hold when relative humidity is 100%, when it's fully saturated, increased it at about 7% per degree centigrade of warming. There was about a degree centigrade of warming attributable to humans in the Gulf of Mexico, where the water's coming from. So I thought that's 7%. But Mark and I came up with the best estimate of 24%. My friend, the late, great, and recently departed Gert-Jan von Oldenburg came up with 16%. And Simon Wang, who I didn't even know at the time, came up with a best estimate of 20%. He's a very interesting scientist at Utah State. And basically taking the average of those, you can say, well, climate change made Hurricane Harvey rain 19% more. That's a lot, actually, when you think about it. Now, I'm going to make a little aside about causal inference. What I'm talking about here is causality and causal inference, and there are two different schools the way to do this. One's called Pearl causality, the other is Granger, after the two people who came up with this or who best described it. And because complex events have complex causes, it's not always appropriate to say this caused that. Now, sometimes it is, and we'll talk a little bit about that. One of these are borrowed from epidemiology. The first one is simple. It's what you do if you have a medicine and you give some group a placebo and some group the medicine, and then you compare the results. We did that with and without climate change in models because we only have one planet. Sir Clive Granger won the Nobel Prize for economics because he couldn't do that by looking at the observed trends, and they both have strengths and weaknesses. What I want to say is that if you get the same kind of result using these two different kinds of philosophies, your confidence is increased. And indeed, Mark and I used Granger causality, and the two other studies use Pearl causality. So our confidence in that 19% statement for Hurricane Harvey is quite high. So now, that was the statement about the weather, but let's get into the impacts. And so the question then is asked, how did this attributable to humans, increase in Harvey's precipitation affect the resulting flood? And so I designed something we call a storyline and say, okay, we'll see what this is in a minute. So I met this fellow from the University of Bristol and the Fathom company who had a model that he'd already run of Hurricane Harvey, and it did a fantastic resolution of 30 meters, about 100 feet, about the size of a suburban yard in Texas. And I asked him, I said, well, what would happen if we took your model and instead of running the observed precipitation to drive the flood, could we change that by these attribution statements that we made, the 19%? And actually, we looked at the complete range over the entire confidence interval. And so that's what we did. And we came up with these maps. And remember, it's 30 meters, which is incredible. Climate scientists generally will operate at much coarser fidelity. So this was really kind of interesting for me. The flood the actual flood driven by observed precipitations up in the upper left. This is a neighborhood I picked because there were 8,000 flooded homes in it, one of the more, so South Houston being one of the more heavily impacted regions. The plot next to it is just a map that gives some perspective for people who know Houston. I've never been there, so I don't know. And on our lower bound, the very conservative statement of that humans only increased it by 7%. The map of the area flooded doesn't look that different, but the depth actually does. The depth is on the right there, and it's about a foot deeper, even with that small amount of human influence. Now, at the other end of the spectrum, at the really highest estimate, which also came from Mark and I, you can see that there's actually a very distinct area that would not have been flooded with climate change, but without climate change, rather, these areas that aren't colored, but are colored in the actual flood. So this counterfactual flood that might have been if climate change didn't exist is substantially smaller. And it's also, so the real flood is actually a lot deeper. In fact, instead of 1 foot deeper, it's actually about 6 feet or more deeper than it would have been without climate change. So now into the cost. Now I know that the insured losses coming from the reinsurance companies say that Harvey cost $90 billion. And so a very conservative estimate would say, well, okay, that 19% increase in rain led to a 14% increase in the flood area. And if properties are all uniformly distributed, say that 14% of that $90 billion is due to climate change. So that a statement that I made in this first paper was that climate change increased the cost of Hurricane Harvey by about $13 billion. From an insurance point of view, they might be more interested in the probability of a $90 billion loss. And basically that going back to that very first figure, flipping it around, we could say that the probability of the $90 billion insured loss was quadrupled due to climate change. But we can do a lot better than that uniform property value kind of thing. And a young colleague of mine at Louisiana State University, Kevin Smiley, took those maps that I just showed you that Chris Sampson and I made, and he took real estate value maps on real estate density maps. And the little hexagons show where things were flooded. You can see it's obviously not uniform. And we came up with some conclusions that a third of the homes that were in Harris County that were flooded would not have been flooded without climate change. That's our best estimate. And furthermore, this flood was so big that 75% of the flooded homes, whether they were flooded by climate change or not, were outside of the FEMA 100-year floodplain and thus likely uninsured. This sort of explains something I didn't understand earlier, that NOAA's estimated loss was 120 billion, whereas the reinsurance estimates were 90 billion. So I think there's like $30 billion of uninsured losses. But we can go further than that. And Kevin also applied census data, and he looked in a socioeconomic way at income and race. He looked at single versus multifamily residences. He looked at mobile homes. And the most interesting result was about race and socioeconomic status. And so if you look at the green, that sort of tells the properties that weren't flooded, which is representative of the population at large. And what I want you to see is that about a third, a little more than a third of this county claimed to be of Hispanic origin. And if you look at the two other houses here, the red one is properties that would have been flooded even without climate change. You can see that half of those homes were Hispanic and most of those were low income. And of those ones that were only flooded because there was climate change, again, about half of those were Hispanic. And we looked at the income as well. And so regardless of which estimate of climate change, of the influence of climate change of precipitation, whether you take 19% or 7% or 38%, these percentages don't really change. And so regardless of any uncertainty in their human influence, low-income Hispanic communities were disproportionately affected. Found some other weird things, that in high-income white neighborhoods, the richer you were, the greater your relative financial damage. But in low-income Hispanic neighborhoods, the poorer you were, the greater the financial damage. That should be damage, not data, I'm sorry. And we interpret that to that these people that were flooded were close to the water. And they probably both had a view. In the rich places, the rich people had a very nice view, and the poor people were probably looking at a refinery or something, because they're close to the water too. Oddly enough, we found no statistical significance in non-white, non-Hispanic neighborhoods. That means African American. And we think that's because of the arrival times of these communities, that the African Americans have been in use a lot longer than the Hispanic communities, but there's some of that speculation. We didn't see much difference in the other things like the mobile homes and single versus multiple residents. Now, I'm trying to extend this to other things with my colleagues at the Pacific Northwest National Laboratory, a very interesting project called ICOM, which is focused on the mid-Atlantic states. We're looking at the remnants of Hurricane Ida and the topography of the eastern states. This is New Jersey, Pennsylvania, and in New York. It's hard to see. I don't have the state boundaries on it. We needed a more complicated model. We get more results from this. The depth is changed due to climate. The change in flood depth due to climate change is on the left. What I'm really interested is in Queens, because in Queens, poor people that lived in garden apartments, which is the euphemism for basement apartments, drowned because the water rose so fast that the water came in, a window at the top of the apartment, but on the ground level, the water flooded in, and these people were mobility limited probably, and they couldn't get out fast enough. And so we can look at the rate of the change in the depth as well. And you can see that's actually different. The change in the maximum flow rate, or the increase in the depth, is different than the depth itself. We estimate that about 5.5 million people were flooded because of in that event. About 500,000 people were flooded because of climate change, who would not have been flooded otherwise. And there's a socioeconomic disparity. The most vulnerable people were most impacted. So what about us? Jennifer asked me to say something about it, and I actually have been. There's a YouTube video at the lab. This is a storm that happened a couple of days ago, and I made a statement that climate change increased precipitation in this storm and the one we're going to have tomorrow by about 5%. And that's based on some work that I did with the San Francisco Public Utilities Commission, where we analyzed 6 storms that they chose for us and we did this storyline thing where we put climate change on them. And we came up with a scaling law that basically the change in precipitation goes at 10% per degree centigrade. There's currently about a degree Fahrenheit, which is about 0.5 degree centigrade of attributable ocean warming off the coast of San Francisco, and that's where the 5% number comes from. But it's going to get a lot worse, and our collaborators with the consultants of the Public Utilities Commission, Mike Mack and Chris May, came up with this picture, which really kind of frightens me. Our colleagues at Scripps Institute of Oceanography down in La Jolla and the UCSD had recently developed a 5-point scale to communicate the intensities of atmospheric rivers. It's sort of like the Saffir-Simpson scale for hurricanes, only it's a lot better thought out. And so this particular storm in 1995 was a Category 5 storm for the San Francisco Peninsula. And what we saw is that, basically everything is Cat 5 in the warmer world. And so they just said, well, let's take the difference between Cat 4 and Cat 5 and add more scales. And at the mid-century, you'd have to go up to Category 7. And at the end of the century, under a really, bad emission scenario where we don't cut back our emissions at all, we'd have to have 8 categories to describe this storm. So the flooding that we get today is nothing compared to what would happen in the future with these things. So I'm just about done here. End-to-end attribution goes as this. There's a degree of global warming, degree of warming in the Gulf of Mexico due to climate change. That caused 20% more rain. That caused 14% more flooded area. That caused 1/3 of the houses, more houses to be flooded. We also found in that study that low-income Hispanic population was disproportionately affected. And I'll leave a question for you. Is this a quantification of environmental injustice? I think it is. This is a contentious subject. I get a lot of pushback on this. But I want you to know what my real goal is to get this end-to-end attribution method, where I start with the change in the temperature and I go all the way to the change in the damages. I really want to get the methodology into the loss and damages discussion so that developing nations can provide what I consider defensible estimates of damages to this fund that you may have heard of that was actually approved by the COP27 in Cairo. So thanks very much. I'm happy to take questions.
Very good. Thank you very much, Michael. Excellent presentation. And we are running ahead of schedule, so we have plenty of time for follow-up questions, comments, observations. Anybody from the CAG here wishing to ask a question or join the conversation? Just
I have a question.
all right. Yeah. Go ahead.
So we're looking at 1 degree change, and you talked about another degree change, and I know we're looking at, like, in terms of time wise, the degree of change it's depending on what scale you look at how rapid it is. But I'm wondering when or what kind of models, or does it deviate and become nonlinear in terms of the increase per degree?
The which aspect do you want to know
Well,
about?
so what you laid out was a 1 degree change, and we saw things, and I think you had mentioned like another degree would cause, extrapolate almost linearly. What point do these numbers and which ones curve more rapidly?
Yeah, that's a good question. I think this whole idea of trying to understand the change in precipitation by just predicting the change in temperature is relatively new. It doesn't appear to be particularly nonlinear. It probably is a little bit, excuse me, because what's happening is the humidity goes up by 7% per degree centigrade. That's pretty much locked in. But there's more energy. There's more energy, what we call latent heat energy, because of the moisture itself. And there's more sensible energy, that's the temperature. And so that energy is manifested in that the storms become more violent. And so the winds are stronger, there may be more lightning, et cetera. That process is not that well understood. But that has to be why the relationship is greater than that Clausius-Clapeyron thing. And so, we've only learned this for we've known it since Hurricane Harvey. That was the first time but I didn't understand it until about 2 years ago, that there's nothing magical going on. It's just that the winds are stronger. That's a more intense storm. And so, so that's that. I mean, the big thing I think is, how much will the temperatures change? And that depends on what we do with emissions. Now, this new thing, the Inflation Reduction Act, goes a long ways for the United States in terms of reducing our emissions, but it isn't anywhere. Excuse me, it isn't anywhere nearly enough. In order to have climate change, stop, we have to have zero emissions, and that's a tall order. That other people at the lab, my colleagues at the lab, are working on some of those solutions. Solar and wind and batteries and that kind of thing.
Okay, thanks, Michael. Marcos, any
Michael.
points?
No more follow-up, thanks.
All right, thank you. Let's go to Katie next.
Hi, Michael. I just had a question about the map that you showed where Hurricane Harvey stuck around the shoreline there for quite a few days. Has there been speculation or determination why that happened, or has that happened since with other hurricanes? You said that was a very weird pattern. I'm wondering if that's been repeated, or if there are human factors at play there, like are hurricanes.
That's a great question. And the reason it's such a great question is, and I pay attention a lot to what's in the press, because I'm in the press a lot. And a lot's what's said is actually wrong. What is true, and a colleague of mine, a co-author colleague of mine on the IPCC report named Jim Cosson, found that hurricanes, once they make landfall in the United States, have slowed down. And there's some evidence that is due to climate change. But the stall is something different. And when we looked at the record, I could only find one storm in the observational record, which is mostly in the United States, that actually behaved the same way. And I made this statement, a friend of mine said, well, what about this other storm? And there was another one that was sort of like that. And so it's such an infrequent event that there's really nothing we can say with any confidence at all. And so, because of Jim's statement, which is true, that storms are slowing down, others have said, well, that stall is partly affected by climate change, but I don't consider that to be scientifically credible. And so one of the things I try to do is be very cautious when I talk to the press, to only say things where, I've got some confidence in it. Now, people criticize climate scientists for being overly conservative, but, I hate to be wrong. And so, I'm going to be that way.
All right.
Gotcha. All right.
Very good. Thanks, Michael.
Thank you.
Any other questions, comments before we move on? Okay, Sarah, go ahead.
Yeah, thanks so much. So I work with the City of Berkeley for our Office of Energy and Sustainable Development, and would love to follow up with you to see if you'd be willing to do a brown bag for many of my colleagues who I know would be interested in this. But also was curious, when you're looking at global warming and impact of more rain, if you're also looking at sea level rise and potentially groundwater rise as well, and that impact on flooding too?
Well, this is kind of a one-man show at this point. So the short answer is no. But and I've been happy to give a brown bag to your group.
Thank you.
What I would suggest is that my colleagues at the San Francisco Public Utilities Commission, are very interested in this result that they paid for, actually, the Atmospheric River stuff, in having that see a wider use within the Bay Area. And so the person at PUC is named Anna Roche, R-O-C-H-E. You can tell her I sent you. And one of the things that's coming out of this project, our role in this project at the Berkeley lab is finished, actually, but the consultants they have are preparing a guidebook, which will have two parts: one explaining the science, and the other providing real actionable information. What was of particular interest to the PUC was something called IDF curves, intensity, duration, frequency curves, which is what they use as a design tool. And with this information that I've given you and given them, and other information that came from other things we did, the consultants have modified these IDF curves and said, under this amount of warming, this is how much worse things are. And so that's that part. Now, the city of San Francisco has also spent a lot of money looking at sea level rise, and they have a separate group of consultants really that are doing that. I should add that this project with the city of San Francisco, as far as I can tell, is the very first time that a city paid for something at a national laboratory. I have to admit, I had to jump through a tremendous number of hoops on the bureaucracies on both sides. If I was paying for the lawyers, I'd have used up all the money right away, but I wasn't, so we got to do our work.
Okay.
So my hope is that this experience makes it easier for the laboratory to get involved with local decision makers on climate change, because like it or not, I mean, the action at the federal level is pretty low. It's people like you, who have to deal with these things that are where the rubber hits the road.
Okay, very good. Thank you, Michael and Sarah. Any other questions or comments here? All right. Well, one thing I might add, Michael, our firm is currently engaged with LA County Public Works to conduct a development of what's being called an equity-informed infrastructure framework. And so we're collecting data on the potential distribution of benefits and burdens associated with infrastructure investment. I'm just thinking that could be another factor to consider in terms of the acceleration of disparate impacts with regard to different community groups, racial, ethnic, income groups that you have in your study. And I would think that some of those areas you describe are chronically underinvested in when it comes to infrastructure investments, and that could add further negative impacts or consequences on those populations. But we haven't concluded anything yet. We're still in the process of collecting data about how infrastructure is currently being funded and distributed throughout the county, but we should be able to come up with some interesting data points that could be of interest to you on that.
Yeah, it would be. I should add that our interests are not just on floods. And together with my colleague, Federico Castillo, who's in the College of Natural Resources at UC Berkeley, We're quite interested in the effect of heat on agricultural workers in California,
Mhm.
many of whom are undocumented, and we see this as a serious public health problem for a lot of reasons, um, um, both having to do with being undocumented and being poor. He started a center for Latinx in the environment, which is extremely popular with the students. We've had a lot of feedback, positive feedback from students on this project. We're still ramping up, trying to get somebody to pay for this. At the moment, I'm sort of doing it in my free time,
Mhm.
copious amounts, obviously.
Okay, interesting. I see Humberto, you have a hand up. Why don't you add in your comments here, questions?
Yeah, thanks, Michael, for such an interesting presentation. My name is Humberto. This is actually my first meeting. I'm a campus planner with UC Berkeley, but prior to this, I worked for an engineering firm, and we would use this kind of this type of model to create like analysis of it would always be around the economic impact of either a flood event or a heat wave event. And I am wondering to what extent you are interested in sort of connecting your research to probably to like the economic analysis that probably like Daniel Daniel or like other engineering firms might be working on to put I guess to quantify and put either a dollar value or to measure the impacts in a way, yeah, in like a more communicable way, I guess, yeah.
Well, you're exactly right. I mean, we can say something about how much the weather changes, and that makes the news. But I think what's really interesting is how much that affects people, and it's surprising. The part of the problem is it's a different community. I mean, I'm a physical scientist. I did physics and engineering in school, and I have to talk to social scientists, and so there's a communication gap there. Federico's an economist. When I lectured his class, I told the students, I said, we have a language barrier, and it's not the Spanish English thing. It's the physicist economics things, which is a bigger barrier, because we use different words for the same things. And so it's interesting in that regard, in that once you get past the language, there's a lot of really low-lying fruit. Now, you mentioned heat waves and death, actually, and that's actually something I'm very interested in. And it's hard in the United States because we don't have socialized medicine, and so databases are sort of hard to get your hands on. They're particularly hard at the lab. We don't really have the good resources for these kinds of data sets that require a lot of legal maneuvering, so you don't, because there's private health data kind of thing concerns. But what we do know from studies in Europe is that when it's hot, a certain number of people are going to die, and you make it a degree hotter, and actually that mortality curve versus temperature is actually very steep. And so small changes like 1 or 2 degrees centigrade actually have a large effect on how many people die. Now, the good news is that kind of information can lead to adaptation. And again, I have to go to Europe because we don't have these studies in the United States because all these other institutional issues. But in Paris in 2000, or Europe in 2003, which is when this event attribution kind of science started. A colleague at Oxford, Miles Allen, dreamed it up. 70,000 excess deaths were recorded during that period. And I think we have good reason to believe that that's how many people died because of climate change in 2003 throughout Central Europe. That's a lot of people. Now, those same temperatures were nearly reached in 2010, but far fewer people, the number of excess deaths, this epidemiology thing, was far less. And that's because people adapted. And they did, you know, they went and they checked on the old people. That was the big thing. And so, you know, that's where I'm sort of coming from, is to highlight that dangerous climate change is already here. And it's going to get worse, but we can mitigate some of the impacts by, you know, engaging the larger community to take measures to protect ourselves. And, you know, there's different things for different kinds of hazards, but it's quite effective. I mean, 70,000 people, 70,000 people did not die in 2010 in Europe because they had learned a lesson 7 years earlier.
All right. Well, Michael, thank you very much again. Let's give Michael a round of applause here. You can show your appreciation here with a digital hand or physical hands. Thank you very much. Great presentation, great discussion, and follow-up points. So why don't we move on to the next presentation, which is by Lou Feldman, who is the executive director of the UC Botanical Garden. And he is relatively new to that position. I know he's been on the CAG now for some time, and we're glad to have him. And we wanted to learn more about what's happening at the Botanical Garden. So we're turning it over to you, Lou, for this portion of the meeting this evening. Go ahead.
Thanks very much. We're going to try and share the screen, which Jen told me I could do. Let's take a look here. And let's see if we get this going here.
It is coming up. We see it.
You all set?
Yeah.
So what I wanted to do in this time is to introduce the garden to many of you who probably have some knowledge of it, to point out some aspects of the garden that you may not know about, and then maybe to open some topics that we might like to pursue at a future meeting, or perhaps in person, you might come to the garden and we could walk to that particular place or discuss the thing you're interested in. So I'm actually a faculty member in the plant biology department, and I've been the director of the garden, surprisingly, for over 3 years. And it's a little bit of a shock to think that the time has gone so quickly. During that time, of course, we had COVID and the garden was closed for a period of time. But because most of our exhibits are outdoors, we were probably the first and only unit on the campus to open to the public for a number of months. So what I'd like to do in the short time I have is really to give you a bit of the history of the garden, talk to you about some of the collections and about our efforts at conservation, and then to indicate to you what types of teaching and research activities go on. And again, what I'd like to do is, if there are particular topics that interest some of you or all of you, I'd really be glad to talk about them more. And more importantly, if you're interested, sometime we could even have, maybe as the summer approaches and the days get longer, we could even have a meeting down here, and then it'd be possible for a walk through the garden or to focus on some of the aspects of the talk today that might interest you. So I'm going to touch on these topics briefly. So the garden has a very unusual mission. Because we're a university garden, it's more than you'd find when you go to a typical botanical garden. And our real mission is to involve the garden in teaching and in worldwide research. And we take the teaching aspect very seriously, and it's something that I'd like to expand. We're working with LBNL to maybe enlarge the level of students who come to the garden, and to attach ourselves to some of the STEM programs that you have at LBNL during the summer mostly, and to become more heavily involved in them. We see you as a resource, and I hope that you look at us as a resource as well. The other aspects of the garden, as far as our mission, is we have a very large obligation for conservation of plant diversity, and I'll touch upon that in the talk. And most importantly, I think for me, is to really promote the understanding of the public about the importance of plants and the natural environment. And this is something that I can tell you, having been a teacher in introductory biology for a number of years. It's eye-opening for students when they are presented with an interesting topic which has to do with plants, for them to understand the importance of plants in the environment. And I think we still have that charge here at the garden, and we work daily to try to address it. So one of the first questions is that I'm often asked is, why have a botanical garden? Why should we invest in growing these plants and watering them and caring for them, and have them grow in an area that probably very few people see? And the answer which I like to give people is that we really are, our future as humans depends upon our ability to partner with the environment, in particular, in my case, to partner with plants. This is an important goal which we have, is to show the public, perhaps more industry or whomever happens to be interested in it, the importance of interacting with this unique group of organisms and the role that they play in our environment. So the garden has a long history. It started quite some time ago in 1890, the 19th century, and it actually began as a kind of a private research fiefdom for the faculty at that time. And the garden began on the campus, in the central campus, and this is a picture of the original greenhouse. Some of you may be familiar with some of the pictures I'm going to show of the campus, although they are from a different time. This is patterned after the conservatory. Some of you may have visited the conservatory at Golden Gate Park in San Francisco. And this is the original plantings that went on. This area here is known as Observatory Hill. And to give you a little better orientation, the garden actually came up to the north-facing face of the library. So if you stood on the library steps and you look toward the north, you would be actually looking at the botanical garden. And when the garden was first started, it was located on the perimeter, at the periphery of the campus. And as the campus expanded, it moved closer to the garden until the land the garden occupied became too valuable to the campus for plants, and rather they wanted to build on it. So the garden, which used to be where this building is now, moved. And this building here, many of you may know, we're standing on those same steps of the library. This is the East Asian Library. This was the land that used to be the botanical garden. So in about 1929, 1930, the garden was essentially evacuated from the campus and moved up here to Strawberry Canyon. This land that the garden occupied used to be a dairy farm. And in fact, we still have a building on the garden property, which was one of the barns for the dairy farm. We're not quite sure what the original landscape was. This shows you some of the plantings which were here when the garden first moved up. There were some eucalyptus, but of course not as many as we now have. And we're not sure what the original plantings would have been like when the Native Americans lived in the area. And as many of you know, the Ohlone Indians occupied this space, and we have evidence of their use of the garden and use of the oaks, many of which we have here on the grounds for making various types of foods. So since 1966, the garden has been administered through the Office of the Vice Chancellor of Research. And this gives us an entree to some of the research activities on the campus, but also kind of sets us apart because the garden is part of the Campus Natural History Museum Consortium. And for those of you who know the campus, that includes the Herbarium, the Museum of Invertebrate Zoology, the Entomology Museum, and a number of other research institutions. But what I want to point out to you is of all these natural history museums, the garden is the only one with living material. It's the only one in which when you go home at night, you can't put your specimens in the drawer and know that they'll be where they are when you come back in a month or 3 months from that time. And so this gives us extra emphasis and push on the collection and on maintaining the collection because they're living materials. Now, what the garden is not. The garden is not a display garden in the sense that we grow 1 or 2 different types of hybrids in masses of color, which I have to admit are beautiful and very attractive, and really are what most people think of when they think of a botanical garden. What the UC Berkeley Botanical Garden is a specimen garden. It is a garden which has plants from all continents, except for Antarctica, from 9 geographical regions, which I'll touch on. We have a number of very special collections. We have a large number of different types of plants. between 13,000 and 20,000 plants. And for that reason, because it's living and because we have this large collection of specimens, many people view the garden or gardens like this as a Noah's Ark in some way. Now, what really distinguishes this garden from most botanical gardens, including most of the botanical gardens which have a bigger emphasis, like the Missouri Botanical Garden or the New York Botanical Garden, is that about 80% of the plants which you find growing in this garden are wild collected. That means that their genetic background, the plants which are growing here in the garden, is exactly the same as the genetic background of the wild plants from which these plants came. And this is important and is going to be increasingly important to researchers, especially as the climate changes, especially as plants which are rare and endangered disappear, and as the urban interface moves into areas where plants are growing and eliminates them from where they are. So if you come to the garden, what you'll notice on our plants is a sign or a label. And this sign or label will have in the upper right-hand corner a number. And this number is important for us, but can be also important for you, especially if you're interested in a particular research topic. The first part of the number, 36, tells you the year the plant was brought into the garden. And the second part of the number, in this case 1234, says that in the year 1936, this was the 1234th plant brought into the garden. But importantly, what this number does is it can take you to our database. And this database is chock full of information which is available to researchers freely. You can get to the database by going to the garden website. There's no code or any kind of password you need. And on the database, you can fill in any kind of query information you would like. And the information will be pulled up and displayed to you. And this has been very much important with regard to researchers who are looking for plants, who are interested in where they grow, what are the soil types, what the climate is like. And let me give you an example of how this database has been used. Recently, we had a visitor from New Zealand. He was from the Plant Protection Unit of New Zealand, and he was looking for gardens in the world which had wild collected New Zealand plants growing. And his job is to travel around the world to visit those gardens which have wild collected New Zealand plants and to look to see what diseases those plants might have or might be susceptible to. And the reason this is he wants to anticipate, or the country of New Zealand wants to anticipate what diseases they need to be on the lookout for to come to their country that would be infecting their plants. So he was able to judge what types of plants we have, how many New Zealand plants we have, how they're growing here by going to this database. And this is the type of information which, when we put it in, we had no idea that that would be the use of it. But researchers are increasingly using this database. And I want to encourage all of you who may have an interest, as we'll talk about, in particular plants or particular environments, to have a look at the database. Now, one of the important things that I want to put in your mind is that because we have wild collected plants, we basically have the stored memory, the DNA of these plants from their original habitat. And this is extremely important, especially since many of our plants are rare and endangered. And many are now extinct in their original habitats or environments. And yet we have them here represented and growing in our garden. And to give you an example of one of the things we're now doing, in California, a large number of plants have been declared as rare and endangered. A project the garden has actually is to seed bank all of those plants, we haven't gotten them all yet, all of those California plants which are rare and endangered, so that we have the original DNA of these plants, and we can, if time is needed, to reintroduce them, as I'll point out in a subsequent slide. Now, the UC Botanical Garden is a garden which grows in a Mediterranean climate. We live in a Mediterranean climate here. Most of our plants, which makes us an extraordinary garden, grow outside because of the Mediterranean climate. We do have some indoor collections. They're kind of specialized, such as succulents, which we have to grow indoors in this case because of the rain. But the plants which we actually emphasize in the garden come from Mediterranean regions, with California, and then the Mediterranean region for which the name is garnered, that is the Mediterranean region of Europe. But keep in mind that there is a Mediterranean region the same distance below the equator as above the equator. And as a consequence, the garden specializes in plants from equatorial regions below the equator, Mediterranean regions below the equator, from Central South America, from South Africa, and from Australia. We are particularly rich in these collections, and they are freely available and growing outside and are easy to see. If you look at a sort of a satellite view of the garden, what you can do is see that the garden is divided, and I'll show you a map, into areas not based upon the taxonomy of the plants, but upon their geography. So we have an area for South Africa, an area for Mexico and America, and so forth. The largest area of the garden is California, which we have over here. And in the California area, which is also pictured in this paper map, we have about 30% of all the species of plants growing in California we have here in the garden. And of those 2,000 or so plants, more than 300 are endangered or threatened. Now, what I'd like to point out for you is that the California section is not only an area where we grow these plants, but is an area where we try to duplicate some of the various specialized habitats which exist in California. And these habitats fall into a number of areas. They are, excuse me, they are from the alpine to the desert. And what we try to do is to duplicate these habitats, to demonstrate what plants can grow in these habitats, and to show how they adapt. And let me just show you, I think I have a slide showing you one of these habitats. No, I guess I don't. This is South Africa, one of the areas of the garden. This particular area of the garden has a soil which is very different from California soil. And so this habitat for this plants from South Africa had to change by altering the soil type. And I want to encourage all of the members of this committee to think about visiting the garden at the end of February, early March, when South Africa will be a mass of color. You'll have to double the number of layers of sunglasses because the color is so bright. It truly is a remarkable demonstration of plant color. This is from several years ago. Things will be much better this year, I can tell you that already. Now, the other aspect of the garden, which some of you might be interested in, is that although 80% of our plants are wild collected, we do have some specialized collections. And one of the specialized collections, which I just want to draw your attention to, is the Chinese Medicinal Herb Garden collection. This garden was started because, as some of you may know, in San Francisco, there were several schools of traditional Chinese medicine. Their students only saw the dead plant material, which they then combined in various ways, depending upon the disease they were treating. And we were approached and asked if we would, given a grant, if we would plant a garden so that the students could see the living materials. And we have this garden. It's increasingly popular, especially with the Asian Americans who visit the garden. And as you go through this medicinal plant garden, the plants are grouped by the drugs that, by the diseases that they are treating. And if you speak Chinese, you get a bit more out of this from the Chinese characters than are on the signs. Adjacent to the Chinese Medicinal Herb Garden is a garden of culinary plants, plants which you might enjoy eating and cooking with. And these plants are coming into flower now and are really, you can walk by them and kind of squeeze them and get beautiful smells and scents on your fingers. Across the street from the main garden, and you at the Lawrence Berkeley Lab know about this, is the Redwood Grove. This is a remarkable structure of plants which was put in only in the late 1920s, early 1930s. We believe it was a WPA work project, and it is a particular California habitat. One of my dreams, which I don't think is going to be visualized or envisioned by the time I leave, is to connect the redwoods of California with the California area, which are separated from each other by Centennial Drive. And my dream is to, to have a high line going through the Redwood Grove so that people could walk through the Redwood Grove elevated above the redwood trees and cross the road and then end up in the California section of the garden. I don't think that will happen, but it's certainly something that I'd like to think about. Another aspect of the work done at the garden, which I touched upon earlier, is conservation. And we receive a large number of grants, not enough, but a large number of grants from a number of these organizations and others to look at particular plants which are considered rare or endangered, or to reintroduce them, or to seed bank them. A couple of plants which are currently being looked at are plants which are either rare or endangered or have not been found in their original native areas. The larkspur, the Diablo buckwheat, Franciscan manzanita, and a plant known as the large flower fiddleneck. Many of these plants, for example, like the Mount Diablo buckwheat, grow on the slopes of Mount Diablo or Mount Tamalpais, which, because they were heavily grazed, the plants were eliminated. And the garden is frequently asked to try and collect seed from the few plants that might be around, and then to reintroduce them back to their environments. And this is a good example. This particular plant, buckwheat, was reported on Mount Diablo. The last time was reported in 1929 or in the 1920s sometime. And in the early part of the 2000s, a graduate student was up on Mount Diablo and discovered that this plant was still around. It had been lost for that 70 or 80 year period. And so the garden was alerted to the presence of this plant. We went up there, we were able to collect seed, and the seed were grown into many, many hundreds of plants from which we collected many thousands of seeds. And then these seeds were grown up into new plants in some cases, but in other cases, they were rebroadcast on the slopes where they originally grew. So this is a very strong effort that we have in the garden for conservation. We are continuing that effort. And as we have more seeds of rare plants in our seed bank, we hope to expand this effort. Here is an example of planting out some of the plants which were rare and endangered. This is the example of the large flower fiddleneck, where we have students and some of the staff of the garden who go out and reintroduce the plants to areas where they no longer are existing, but where we know they originally came from. But toward the end now, I just want to talk about our role in education. For me, coming to the garden, as I said to you before, education is probably the most important role that I can foresee many of us having. Unless we're able to generate interest and fascination with the plant world, I think we as humans are really doomed. We have a large number of education activities. We have a large number of students who come from both the campus and from outside, and I want to expand, if possible, hopefully working with the labs to be able to tag on to some of the very talented students whom I know you get. The garden is used for research by faculty. In this particular case, pictured in the right, is a faculty member who is interested in the physiology of redwood trees in the top part of their canopy. His students go up to the top of the canopy. Many of you may know that we now have discovered that redwood trees can actually absorb moisture from the fog in the leaves, and that moisture itself, the fog itself, contains nutrients from the ocean, minerals from the ocean, which provide extra sort of fertilizer for the plants. Sometimes the garden has a less than botanical interest. In this particular case, we have an architectural design class who were interested in asking whether there was some activity that they could become involved with. And in this case, they built a bridge. Again, the idea of trying to invest the students into doing something practical, but also providing something for the garden. So we have outreach programs. We have, in this particular case, about 1,000 students have participated in family summer programs and in camps. And during the year, we have about 6,400 people participating in our public programs. Of that 6,400, about half are coming for our concerts, which we hope to begin again this summer now that COVID has passed. And I'd encourage all of you, if you're interested, they're remarkable to have them in the Redwood Grove. How do we increase the number of plants in the garden? Well, there are expeditions. In the old days, you would be able to go into any country. This is a book written by a former director of the garden, Plant Hunters in the Andes. Today, it's dangerous to go in other countries, and also many countries have imposed restrictions on the collection of plant materials. So most of the new plants which we get from other international venues come to us from colleagues who wild collect seed and then send us that seed, and then we are able to increase our collection. If you're in the United States, specifically in California, we do have collecting. Here we are in the Mojave Desert, and in this particular case, we can do the collecting ourselves. But this is increasingly a decreasing activity. Most of our growth in our collection comes from colleagues in other countries sending us materials. Sad but true. Now, I'd just like to end by talking about running a garden. It's not that easy, as it turned out. First of all, the garden has about 30 employees, and those employees, about half of them are horticultural staff. They actually tend to the plants, and the other half do things like programs, rentals, gift shop, and so forth. These are the activities which generate our support for the garden. Our budget is about $4 million a year. Most of that is for salaries, and we depend a lot on donations. We depend on memberships, and it is always a particularly challenging pursuit for anybody, including for me. And so finally, I'd just like to end with this slide here to encourage those of you who are not members or who have never visited the garden to do so. We have docent-led tours, which are really educational and very enjoyable. The volunteers and docents are extremely knowledgeable. Many of them are very accomplished in whatever career they had prior to coming to the garden volunteering. There are lots of benefits to being a member of the garden, in that you have a lot of opportunities for programs, and there are a lot of chances to meet some very interesting people. We have reciprocal sort of admission with other gardens, and we also have activities which allow you to learn about other gardens. So with that, I just want to say thank you for letting me introduce the garden to you. There's much more here than I had a chance to go over, but I want to encourage you to come down, and maybe Jen and I can arrange for a warm summer night for us to hold, or near summer night for us to hold our meeting here in the garden.
All right, Lou, thank you very much. Let's give Lou a round of applause here. Great presentation, tremendous overview. It's been a while since we have met at the garden in person, so I appreciate your offering there, because we have had CAG meetings there in the distant past. Any follow-up questions or comments for Lou before we move forward?
I've got a quick question. Oh, sorry, Sarah, go ahead.
Oh, I didn't mean to cut you off, Jen. Whoops, I keep freezing. That was so interesting. You really packed it full of incredible information. I was like, oh, I didn't know that. A WPA project? Who knew? This and that. And I just wanted to put a plug in also for how wonderful your gift shop is. So if you are ever looking for gifts for people, I highly recommend it. And obviously you shared so many new things that I will eagerly keep an eye on when I go to visit. So thank you.
You're welcome.
That's great. Thanks, Sarah. Katie?
Do I remember also perhaps this past year that there was a time that the garden had a particular sale events on various types of native plants, et cetera?
So we used to have these 2 annual sales a year, and then when COVID hit, we stopped. So what we've done is what you recall, which is to have some smaller specialized sales. So we had a specialized sale for carnivorous plants, a specialized sale for indoor plants, a specialized sale for California natives. And we're continuing that just because what has happened, and Michael knows this, we have lost part of our parking lot as a result of the Centennial Bridge building project. Right. And as a result, we have had to reimagine what space we use to grow plants. And that has reduced it somewhat. And so we probably will continue the smaller sales until that is finished, and then move back to the larger ones that you may recall from the past.
Okay, Jen, why don't you go next?
So I've got a couple questions, and I agree with Sarah. I learned so much in your talk. Even though we chat quite frequently, it was a fantastic presentation. My first question is, how is the garden sort of planning, long term for climate adaptation? And my second question is, as you're collecting new species, how do you just you've got sort of a physical space. How do you decide when to bring in new species? Where do you put them? Is there a big reorganization that you have to think about as you add new plants to the collection? Yeah.
Well, for the first one, let me just say, and this is some a fact which escapes people often, given the fact that we have plants from many, many different environments, many different geographical zones, and more or less all of those plants which we now have assembled together are growing in the same climate. One of the aspects that we're beginning to focus on is asking, as the climate changes, which of these groups of plants are beginning to adapt, or are able to adapt, or are able to grow well. And if you're a molecular biologist, what you begin to do is to ask, what's common about the genetic information in these plants, which might give you some indication of how they're able or why they're able to adapt to an environment. So we really do feel the collection has a great potential for helping us understand the genetics and the molecular biology of adaptation to climate change. And it's something which hasn't been exploited yet, but it's an idea which I think will come to the fore soon. The other question had to do with how we decide what plants to bring into the garden. And I think that we always are limited with space, but I think what we're trying to do is to represent in our collection the types of plants which are in many ways rare or endangered in environments that these plants potentially might disappear. The more common plants, although we have some of them here, we tend not to focus so much on them because we know people can find them other places. It's the rare ones, it's providing an arc, you might say, that we really are focusing on here at the garden. Yeah, it's a very good question though. We've always had that problem.
Do I remember that the garden, or is it UC Berkeley or both, that has that that corpse plant?
Yeah, no, it's the garden, right. Now, that's a very interesting plant because
Always astonishing when that thing blooms.
yeah, because we never can predict when it's going to bloom. And so that's the problem. But you have a good memory.
Okay, any other comments, questions, feedback? Well, in that case, we will make our move to wrap up things here this evening. I did just want to see if there's any members of the public who are not officially members of the CAG that wish to make any comments this evening. Okay, not seeing any there. Just want to again remind you of the upcoming dates. The next meeting is March 13, and the other dates were sent out and also put in the chat. So take a look. And then finally, Maria also sent around a proposed set of CAG topics of interest. That's been an accumulation of different discussion items that you as members of the CAG have brought up. We put them all in one place. So as you think of different topics for future CAG meetings, please email Jen and we'll be able to respond and plan ahead to have those topics addressed in future CAG meetings. So we're always looking for topics of interest, and we certainly have a treasure trove of staff at the lab and elsewhere who could be brought in to address all of these different interesting issues and topics of our day. So with that, we're going to wrap up today's meeting. Stay dry, stay healthy, stay connected, and we'll see you next time in March for our meeting on the 13th of March. All right. Good night, everyone.
Thank you,
Happy
everyone.
Thanks, everybody.
Thanks, Jen. Great meeting.
Thanks, Jen.
Cheers, everyone. Bye-bye.